leads to a failure? I got a quick polling question I want to throw up. I'm diving in here, but Vanessa, can you throw up the polling question on experience? Has anybody, and I forgot to ask this right off the bat, has anybody been to a structured training before? Compressor training, refrigeration training? Vanessa, if you can throw that polling question up. I get real excited, Sergey, when I'm talking about refrigeration, and I forget the process sometimes because I get real excited. So Vanessa, you able to throw that polling question up?
1 minute, I'm just going to organize it.
I'm going to keep going. So you'll see a polling question pop up, everyone.
First question, yes?
Yeah, the first polling question on experience. Or the last time they've been in a training, a structured training.
Please see your screen.
There you go. So it just popped right down. So just pick, have you been into, the last time you attended a structured training, compressor training, 1 to 3 years ago, 3 to 5 years ago, 5+ years, or never? Because I wasn't, to be honest, I wasn't at a compressor training until I started working for a compressor manufacturer. And that's my own fault for not taking the initiative and investing in myself. Okay, fantastic. That's great. So like the 67% have never been to a structured compressor training. I highly recommend wherever you're at in the world, if you get the opportunity to get into one, an in-person one, do it. If you can join online ones, get into programs online, like some of the ones that I'll talk about later, you need to invest in yourself. So let's continue on here. So it's important to understand when your system has contamination and what to do about it. You may have to drain the oil out of the system, put new oil in, new filter dryers, clean that up, because there's lots of different types of contamination. Once again, I said us as technicians do it. I remember reaming out pipe and, you know, copper falling into the pipe. Oh, hopefully the filter will catch that. Oh, hopefully the screen will catch that. But that contamination of that little piece of copper can make its way back to the stator of the compressor and short out the compressor. And this is why you need to pull the compressors apart and look inside. If it's a semi-hermetic compressor, pull the head off, look inside, pull the pump off. And if you want to get even more involved, if you have the compressor at your shop, you drain the oil and you check the stator. If you have a short, right? So these, as technician, this is what you need to be doing. Next one, overheat. So I have them in bold. I'm going to dive a little deeper into the ones that are bold, but overheat is one of the leading cause of failure for compressors. Doesn't matter what compressor manufacturer is, it's one of the leading causes. And what's good about compressor manufacturers, all the big ones now, they're coming out with new solutions, you know, so DLT on the systems, or electronic components that'll protect the compressor from overheat. So it'll shut it down, open the contactor to make sure you shut it down before you have a failed compressor. So as a technician, when you have something tripped in the field, something goes off, you need to understand that something is the problem. You know, there's no such thing as nuisance trip. My compressor just doesn't trip off nuisantly. My oil failure doesn't trip off on a nuisance trip. Something happened. You know, it could be a loose wire, it could be actually low on oil, it could be tripping off its internals, but something did happen. So you need to make sure when something does like that happen, you need to be a detective and figure out what's going on. We'll dive into overheat. Loss of oil is another big one. You can't see inside the system. This is one of the things that's been the hardest thing for me to troubleshoot, especially if there's no sight glass on the system. Oil management systems can be difficult if you don't understand. Where's the flow? What is the pressure? What is the temperature? And is there an oil feed line? Is there no sight glass? Okay, if there's no sight glass, what do? How do you check it? Well, there's different ways to check it. You know, you need a thermal imager. You use your temperature probes. Maybe you need to drain the oil. You may need to cut out the compressor, drain the oil to see how much oil was in there, and put oil back in and install that same compressor back in if the compressor is still good. You know, this is part of our job. It may take longer, but that's what you need to do. I never measured the oil because I didn't work on a lot of small stuff, but I did work on some. I never ever measured the oil of hermetic after the compressor failed, but that is the number one thing You'll check any hermetic compressor manufacturer that doesn't have a sight glass. That's one of the main things you need to check, because how much oil is in that compressor? Because there should be at least 95%, so 90 to 95% of that oil in that compressor should still be in there. You'll see on the Copeland compressors, they have a recharge. So the service compressor come back with less oil than the manufacturing compressor. Well, there should be almost around that amount in that compressor that you're taking out. If you dump it out and there's no oil in that compressor, where's all that oil? And then if you don't have a leak in that system, well, where's the oil? And you do not want a big chunk of oil come back and smash your compressor up. So loss of oil is a big one. Flooded starts, another thing. This happens anytime that refrigerant condenses or stratifies in your oil in your compressor. That refrigerant wants to travel to the coldest place in the system. Coldest place, if that's the compressor, it's going to make its way there if you don't have the proper components installed, like pump down, for an example. And we'll get into a little bit more of that. Crankcase heaters. Slugging is another one. Compressor slugging. And as you can see here, you got damaged discharge valves, you got smashed rods and pistons. And this is due to trying to compress a liquid. It could be oil, it could be refrigerant, but you need to understand the difference. You need to understand that slug happened from oil, or did it happen from refrigerant? And you'll see this. I've seen it a lot. I've seen scroll sets just crumbled into nothing because of major flooded starts. And a major flooded start on a refrigerant cooled compressor is a slug. Floodback is another major issue, and this is one of the leading issues for CO2 compressors right now. Failing CO2 compressors out there. If any of you work on CO2 systems yet, if you're in commercial refrigeration, you're going to start seeing more CO2 equipment. It doesn't matter where you're at in the world now, they're coming out with new technologies where you can, even in the hottest climate, they can make this CO2 systems more efficient. But floodback, anytime that refrigerant is making it back to the compressor while it's running, and it's important to understand this. This is why checking superheat at the outlet evaporator is so important. It's so important to check it at the inlet of the compressor on that suction. That's why you need to do these checks. We're technicians. You need to be doing this. And you need to check superheat at specific times. And we'll talk about that in a little bit. If you have any questions, throw them in the chat. I can't stress that enough. This is a perfect time to ask questions that you're looking to get answered. So these are the main 6 types of mechanical failures, mechanical issues, I guess, because sometimes it's not always a failure. But 80% of the time when you're out in the field and you go out and you have a failed compressor, you're going to go up and it's electrical failure. So sometimes you get your gauge on, it's still pumping, but it's not pumping or anything. So you get smashed rods or pistons maybe, or smashed roll set, but it's still running. But a lot of times, 80% of the time, you're going to go up to a failed compressor and you're going to try to ohm it out, and it's a dead short, it's a turn-to-turn short, or it trips the breaker right off the bat, boom. That electrical issue, 80% of the times from that mechanical failure. So if you're not looking inside the compressor to figure out what caused that electrical failure, how do you know what caused it? And how long until that second compressor lasts? Because you should be doing a service to your customer, right? And figuring out what the problem was. So that compressor lasts 15, 20 years. And it doesn't matter. The big compressor manufacturers, Copeland, Bitzer, all of them, their compressors will last a long time. A lot longer than what I've seen them when I did work for the manufacturer. I've seen them coming in after a month, after 2 months in the field, and after 2 years, 3 years coming back. That shouldn't be coming back. That is system related issues or improper installation or improper service to the equipment. Yes, if the customer does not want to do a maintenance, does not want to clean it, and it can be the customer's fault. But realistically, most of the time, it's our fault as a technician, because I've done it where I didn't go and take that extra step to make sure that that condenser was clean when I went to do that service call. Right? You need to do that stuff. You need to talk to your customer about this stuff. But 80% of the time, you get those burnouts, those electrical failures. That's caused by these mechanical failures. One of these 6 mechanical failures. So compression ratio. Compression ratio is something as a technician that I did not always look at. As a technician, I learned about it in school, because we have some great schools here in Canada and apprenticeship programs. And I know we talked about it in there, and we briefly went over it, but there's a lot to learn in the 4 years. Here it's a 4 or 5 year program, but there's a lot of information, but you need to study outside that. Just because you go to school and you do a year or 2 year program, you still need to study outside that. As a technician, you go work your 10 hours a day. You should be reading half an hour a day, either on personal development or on refrigeration or air conditioning, whatever you work on, so you get better. So you do not stress and you have confidence when you go to work on a problem. But compression ratio is something I did not think about or use. But compression ratio, what is it? Anybody in the chat? How do you check compression ratio? Anybody know?
Yes, Trevor. Do you need help about?
No, I'm just asking a question to everyone. It's all good. See if anybody knows how to calculate compression ratio. This is it. Absolute discharge over absolute suction. So you need to change your gauge pressure if you're using a set of gauges into absolute. Maybe you're using digital gauges and you can turn it maybe into absolute. So what you need to do is, this is imperial units. If you get 275 PSI in your discharge, you add 15 PSI. So atmospheric pressure is 14.7. For us as technicians, 15 is going to work. Yeah, thank you very much, Edwin. So 290 PSI. So now I got 55 PSI in my suction and add 15 PSI to get absolute. So 70 PSIA. This is my compression ratio, 4.1 to 1 compression ratio. Is that is that good or bad? Well, it all depends. Like, what type of system are you working on? Is it an air conditioned medium temp or high temp, medium temp, low temp, AC, heat pump? What should the compression ratio be? Well, you need to check with the compressor manufacturer that you're working on, right? Because low temp application is going to have way higher compression ratio. And when you're working with compression ratio, it's a lot more. When you increase the compression ratio, a lot more work, a lot more heat. And that can lead into issues down the road. So if we're talking about metric units, so you get 19 bar on your discharge plus 1 bar. So a bar is 14.5 PSIG. So 1 bar is 20 bar, eh? So bar absolute. And then in your suction, you get 4 bar, approximately add 1 bar, 5 bar. So now I got 4.1 to 1 compression ratio. And this is important because as that compression ratio starts to increase, more work, more heat can be less efficient. Well, it's going to be less efficient. You always want to have, if you can as possible, the lowest possible discharge pressure, and you want to have the highest possible suction pressure to maintain your system. Because when you decrease your head pressure, your condensing temperature, you're getting more efficient. You get more work out of the compressor. When you increase your suction, you get more efficient as well. So I think every PSI you can increase your suction is about approximately 2% more efficient, approximately. Once again, you go into the compressor manufacturer and push these numbers into their programs, and it's going to tell you. So overheat, you need to always check that discharge temperature every time. Every time you're checking compressors, you're servicing compressors, troubleshooting compressors, you need to check the discharge. And if you're working on a system with 5 or 6 compressors, whatever compressor is running and has the highest discharge, say they're all running around 160, but this one compressor is running at 230. That's probably the compressor that something's going on. You're running into issue, valve plate problems. Maybe there's some sort of issues in there. But if you measure semi-hermetic 6 inches from the discharge port and you're getting over 225, that means inside the compressor, inside the head, those service valves are running 275, 300, 310, 325. As it rises up, as it gets warmer, it's hotter inside the head. So it's probably 50 to 75 degrees hotter inside the head. And at 300, you start to lose lubrication. At 340, 350, doesn't even matter. When you start to get that high, you're losing lubrication, but then it starts to break down, which causes contamination in the system. So you can see when you open up a compressor, maybe it's not only one mechanical issue that causes failure. I've seen it up to 3. First one, okay, you go and you check electrical. That's one failure. You look inside the compressor, there's massive overheat. Also, the massive overheat was another issue. And then the massive overheat was due to high compression ratio, or floodback, or loss of oil, because now you start to seize up the compressor. So there's so many different things, and you need to put the pieces of the puzzle together. So if you look 6 inches or 150 millimeters from the discharge, 225 or 107C, when you're running that hot, there's something going on. Unless it's a low temp compressor, and you have a higher compression ratio, but you should have some sort of additional cooling to help you with that. Every degree you increase in your suction is a degree increase in your discharge. So if you have failing suction insulation and it's outside and it's on a roof and it's a super hot day and the sun is pounding down on that suction and that insulation is not penetrating or keeping away the heat from the from the sun, that'll be making its way back to the compressor. That's why it's so important to check your return gas temperature, your suction gas temperature. High return gas, just like I just talked about this. If there's no insulation on this line here, that you can pick up a lot of heat and bring it back to the compressor. And then if you're running through a hot attic, for example, if that insulation is broken down and you got a hot attic, it's going to pick up all this heat, bring it back to the compressor, and start overheating the compressor and tripping off on its internals. So overheat prevention. So Vanessa's going to pop a poll up here for the second poll question, but always maintain those compression ratios. And you need to figure out what should the compression ratio be.
One moment, Mr. Trevor.
Yeah, so Vanessa's going to pop up a polling question for you. There you go.
Yep.
Is it correct?
Yeah, it's perfect. What causes a spot burn in a compressor? Okay, just take your time reading what causes a spot burn. And what is a spot burn? Maybe you don't know what that is. A spot burn is actually where you get something inside the winding and you'll see it and it causes a short. And it's usually from what? Almost gave the answer away there. I get excited sometimes when I'm talking about compressors and refrigeration, and sometimes I get ahead of myself. So for overheat prevention, always maintain those compression ratios per manufacturer design. You'll see an air conditioning system that's usually around 3 to 1, 4 to 1. When you talk about medium temp, maybe it's 5 to 1. Low temps, it's usually around 10 to 1, 12 to 1. These compressors are designed differently. You cannot take a high temp or an air conditioning compressor and then all of a sudden just put it in a low temp application. They're not designed the same way. And here we go. So we got a lot of different answers. So what usually causes a spot burn in a compressor? A burn throughout the motor winding. 3 people selected that. Dirt inside the system or mechanical damage. 5 for that. Relays, capacitors, wires. 1 for that. Lead terminal shorted. So it is dirt in the system that will cause that. And usually it's from, a little piece of copper or a piece of metal that fell off from, a damaged component inside the system, like a compressor take a slug or something. You want to make sure you set the low pressure control inside that compressor operating envelope. I have 2 images here, thanks to Emerson and Bitzer. These are out of their information. So from their website or from their apps, you can get this information. And it's so important to understand how each compressor works, their operation envelope. But if all of a sudden, if you start setting your low pressure control way down here, and this one actually you can go outside the compressor operation envelope a little bit, but if you run outside the envelope all the time, that's going to lead to issues with your compressor, which potentially will lead to a failure if you don't fix it. For example, if you're running either one of these compressors and you're running this Copeland compressor at -40 or this Bitzer compressor at -25, totally different compressors, you can run the low pressure control to make sure you pump out that evaporator when you're doing a pump down, for an example. But you do not want to run, say, the temperature control, just say you're running it off temperature control and you're running it at -25 and it just runs outside there, because now You're doing more work, more compression ratio, and leads to issues with the compressor. Do not let suction pressure go below compressor design. And additional cooling methods may be needed. I'm even seeing this now in heat pump applications. But low temp application, do you need a fan? Do you need liquid injection? Do you need some sort of cooling happening? So these are stuff you need to understand. And each compressor has different manuals, and you need to understand how they work. Flooded starts. There's an accumulator here. Accumulators do not protect against flooded starts. So if your accumulator protects against your floodback, but it's not protecting against the flooded starts, what happens if the compressor system is off, not running? You don't have a pump down system. You don't have a crankcase heater. This refrigerant here, liquid refrigerant, can start to boil. And the compressor, if the compressor's coil, is going to travel through the accumulator, and it's going to start to drop. The vapor is going to get in here, and it's going to start to drop into liquids. It's going to stratify in here. And that compressor starts up, and bam, you have an issue. Okay. And then certain applications you may need to have, you can see here, maybe it comes back from the discharge down the condensing line. And then bam, you get a slug. You may need a check valve here. This is why it's important. Depending on the application, you need to read and understand what you need. And sometimes this is missed by the manufacturers that build the equipment. So it's your job as a technician, engineer, to figure this stuff out. You know, you got to dive a little bit deeper on those problems that you don't really understand. Ask someone, you know, do some research. Don't just say, okay, well, I don't know what happened, I'm going to the next job. Write it down, have a notebook, have a journal, and write down the things that you don't understand, and then learn those. If you want to get better, you want to be the best technician out there, you need to invest in yourself. And by following up on the stuff that you don't know, you're going to learn that over time. Once again, you don't have to learn it overnight. Refrigeration is a lifelong journey, for sure. And this is kind of what it looks like. You know, you get a slug and then it's all smashed up here. If you open up a scroll, it'll look like this, scroll galling. And so you should always have an oil film in here. And we all know refrigerant is a good cleaner, a good solvent. So that liquid refrigerant explodes up into the scroll set and washes all this oil out. And this is kind of what you get, some scroll galling, which leads to issues with the compressor, you know, gas bypassing through these different flanks here. So lots of issues. Once again, if you have any questions, just throw them in the chat and we'll get to them at the end. Flooded start prevention: install a crankcase heater, use a pump down, use a bump start cycle, you know, correct refrigeration charge to oil ratio. Refrigerants actually chemically attracted to oil. So something I only learned a few years ago. Put the compressor in a warmer location. Here's a great bulletin by Copeland. Must read. Even it doesn't matter what compressor manufacturer you work on, compressors, this is a great manual to read. Once again, crankcase heaters, they go in a specific location. So you need to check with that manufacturer where they want to have that. Floodback. Floodback is another major issue. Like I mentioned earlier, in CO2 applications, they're seeing, like, manufacturers of CO2 equipment are seeing a major increase in failed compressors due to floodback, because you need to have a specific amount of superheat at those compressors. Okay, so what's floodback? I talked about it earlier. Anytime that compressor is running, you know, and liquids returning to the compressor, and then you have no superheat. Okay, and how do you check superheat? You need a temperature and pressure probe at the compressor. But if you have no superheat, liquid refrigerant will come back. It'll drop into the oil, and this could be what it looks like in this picture. So you need to check that picture. You need to check that and see, am I actually flooding back, or is it just really cold? Is the low temp application and there's a lot of humidity in the space? But you need to check it. If you don't check it, you don't know. You know, so all of a sudden the droplets fall into oil, and then this crankshaft starts to pick up oil, refrigerant and oil, and by the time it gets up to the main bearing and bushing and drive bearing, it starts to wash away that oil. So then it leads to this. Leads to damaged scroll, damaged bushing, bearing, and it's so important to be inspecting these compressors. If you have not inspected the compressor and you don't know why it failed, how long till that next one lasts? So, okay, I got a question here. Please explain the reason of overheat and flood start. Well, the reason for overheat could be condenser fan motor burnout. It could be the condenser's plug. It could be low on refrigerant. There's lots of different reasons. Your low pressure control could have failed. There's lots of different reasons that overheat can happen. And flooded starts, well, maybe you don't, the crankcase heater has failed on the compressor. You know, anytime that it's going down, you know, maybe your pump down solenoid stuck open. Maybe your liquid line solenoid is leaking by too much. Maybe there's something jammed in it, and that refrigerant makes its way into its compressor, into the compressor. So here it is. This is how you check it. Compressor superheat, you check your temperature, you check your pressure, and then you do your equation. You take your suction line temperature for this example, R448A, or 22 degree Fahrenheit, 26 PSI or 1.8 bar. So you need your pressure temperature chart, and you need to use dew point, and then look, 2 degrees F. So that is a 20 F. Oh, for saturated temperature, it's 1.8 bar on 448A, minus 17 C. So minus 6 by minus 17 is 11 K. Okay, so you need to take a look at this. So the reasons for ice generating on pipes is that say that liquid line is really cold. Okay, you have really cold liquid line, or the suction line in low temp application, you don't have any insulation on. Condensation is going to stick to that pipe if you have high humidity, and then that's where you'll start to see ice build up. So it's not always flood back happening. I've seen compressors with 4 inches of ice on them before, and they had the proper superheat. Always set superheat according to TX valves, superheat according to manufacturer spec. Never set up your metering device in your evaporator to maintain the specific superheat the compressor manufacturer is looking for, because sometimes your piping is not long enough, and maybe you have a plate heat exchanger and you're only a few feet from the compressor, and they're looking for 10 degrees or 12 degrees superheat at that plate heat exchanger or the evaporator. You're not going to pick up 8 degrees of superheat in 4 feet of pipe, but you need to be aware that you do not want to be running low superheat. Okay, system checkpoints. I'd love the people to start throwing it in the chat what checkpoints they would do. You know, when you're going on a service call, you're doing a commissioning, you're doing an installation. What are some of the checkpoints you would do on a system? I'll give you your first couple. Okay, suction pressure, suction temperature, discharge pressure, discharge temperature. You should be doing these ones every time. Okay, and on top of that, you know, these are just the beginning, but it gives you a lot of information on what's going on with that specific compressor, because then you can go into their electrical specs and find out what is going on. You know, is it running inside the envelope? Just by these ones here, you also need the amps and volts, but you can see where that compressor is running in the system. You also need to get your air in and air out. What's your delta T across there? Is that condenser plug-in? You need to get your subcooling, so your liquid pressure converted to temperature, your liquid temperature, and your condenser out. And this will also give you your TD. So you take your air into your coil versus your SCT. You know, check your temperature across your filter dryer. If this is starting to, your outlet temperature is colder than your inlet temperature, well, this is starting to plug up. Okay, check the sight glass. You got moisture, you got bubbles in there. You know, check your subcooling at the inlet of your metering device. Minimum, if you can't check it there, you check your temperature, so you know if there's any temperature drop in that line and figure out what's going on. Air in, air out of your evaporator. Okay, then check your SST, your evaporator pressure, temperature, and superheat. Then check your TD, which is your air in versus your SST. If you have a suction line filter, what's it doing in there? Why is it in your system? You got to understand that. Why is that suction filter in the system? And definitely, you need to replace those. You got to quote that into your job. You'll look at all the manufacturers that make suction filters. If you're doing it for an asset cleanup, you have a burnout, electrical failure, and you put it in, they're recommended to take it out. There are areas where they'll say, okay, if it's a permanent install, there's this much pressure drop that it'll be okay. But I highly recommend pull it out because it starts to plug up. You get a pressure drop in your suction, which is way worse than an increase in your discharge. Your compression ratio increase, and that leads to issues with your compressor. And then your compressor superheat, which I talked about quite a few times. So we got one more poll. Vanessa, you want to throw that poll up?
Yeah, just one moment.
Next poll, correct?
Yep.
Okay, one moment.
Yeah.
So while people are okay, well, let's wait for that poll to come up. Actually, I can pop it up. Oh, there we go. Thanks, Vanessa. So which of the following thermostatic expansion valve condition could lead to compressor floodback? Loose or poor connection of sensing valve, plugged or disconnected external equalizing line, plugged or disconnected. Oh, I put that question there twice. Look at that. Oh, we've got one person says all of the above. One person says plugged or disconnected external equalizing line. I'm also going to throw in a chat while people are answering this polling question. I do have a free compressor training guide. You can just click on the link, enter your name and email address. And if you want to sign up for the free compressor troubleshooting guide, as well as subscribing to my video newsletter, you're more than welcome to. Trying to get a lot of information out to technicians out there. So 1 minute gone by, that's a lot of people. So the answer for that is all of the above. If you have a loose or poor connection, you could cause a flood back, right? Because that suction line is supposed to be cold. And then if you're off and the ambient's warm and it's not insulated, the warm air is going to push the pressure in that bulb onto the diaphragm, push it down, open up the TX valve, and potentially add more refrigerant to the evaporator than needed. If you plug that external equalizing line, that external equalizing line is a closing force. So now if there's no closing force, all of a sudden that valve is going to want to feed more. So never plug, never cap an external equalizer line. It's supposed to take the pressure downstream of that bulb when you have a distributor, we'll say. So thank you very much for answering that. Once again, I threw that free guide into the chat. So if anyone wants to go there. Mobile apps. This is so important. I know we're getting closer to the end. You need to have different mobile apps to help you troubleshoot as a technician. When I first started out, there wasn't a lot of cell phones. We had really mic phones. That's what I had, was a mic phone, a big, thick block mic phone. Motorola, I believe, when I started out. And I was lucky to have that. Because even before that, you guys were using pagers. But now there's so much opportunity to learn, to get better, to teach yourself, and to find the answers out quicker. So here's the apps that if you don't have it, I recommend, depending on where you're at in the world. Some of them may work better than others, but like Emerson AE Bulletin apps. Find out anything here for North America. It's going to tell you all the information you need for any of the compressors here. And it relates to other compressors globally. So if you're in Europe, it'll definitely give you some pointers and tips. You need to go to the European website to get those bulletins if you want the specific bulletins. The Bitzer B-Spot, I'm pretty sure that's global. Danfoss RefTools, same thing. PT charts, there's lots of troubleshooting information in there. Copeland Mobile app, you need that app, especially if you're here in North America. I think it's in Europe as well. It's not as developed, but it's getting there. You need that. You need to go into diagnostics feature. I do a whole training on just understanding how to use these apps. And then HVAC school, for text, by text. This is a friend of mine, Brian Orr. There's lots of great podcasts on there, lots of great tips and tricks. If you're in the HVAC side of the industry, you need to get those. Okay, educational resources. Okay, r744.com, cooling, CO2. If you're into CO2 information, they have a ton there. HVAC school, text by text. HVAC know-it-all if you're into HVAC. The tool shed. This is really for, you should be doing this at job box talks or toolbox talks with your service manager, your team, to help you motivate you, give you a better understanding for customer service. And then HVACR videos. My friend Chris Stevens, he does tons and tons of commercial refrigeration videos to really help teach and show and educate people on how he does it. Is there other ways to do it? He says it all the time. Yes, there's other ways, but this is how he does it. And he tries to make it easy for you as a technician to understand. Okay, fantastic. If you have any questions, throw in the chat. So I have a 4-week compressor masterclass coming up. Like, I've talked here for almost 40 minutes. And as you can see, I'm very passionate about talking about compressors. But when I was in the field for, 6, 7, 8 years, and I said it earlier, I thought I knew a lot about refrigeration, about air conditioning, about HVAC, about troubleshooting compressors. I was totally mistaken on the information that I knew, because I didn't know what I didn't know. And I wish I would have known what I know now, and that's always a saying that goes. But what I want to do and why I built this 4-week program is to help technicians become really skilled, ensure that they're troubleshooting and understand what they're troubleshooting when they're troubleshooting systems and compressors, and have that confidence. If I can share a little bit of knowledge that you'll save a half an hour of troubleshooting, or you'll reduce the amount of callbacks that you have, or you will reduce the amount of compressor failures you have, that's going to bring a huge amount of value to your company, to your customers. And this is why I built this program for technicians, for engineers, to become a better technician. And I want to share the 17 years of knowledge I have with you, so I can speed up your knowledge, right? I'll hopefully fast track you a bit, and you learn a few things. It starts Saturday. It's going to be 4 Saturdays, 2 hours each Saturday, starting February 26th. You can go to refrigerationmentor.com/events. This is kind of what the page looks like right here. This explains a little bit about the course. If you go click learn more, it's going to talk about the course a bit more, and it's going to dive into more of the details of what's going to happen, because I'm going to be sharing my knowledge with you. And this is a course you do not want to miss. Even if you're 6, 7 years into the industry, I say this is going to be really good for you. And if you're new to the industry, 3, 4 years in, it's going to give you a ton of value to bring to your customers, bring to your company. And with this knowledge, you take it with you. You know what I mean? So if you move to another country, you're going to be using this knowledge. If you're going to another job, you can bring this knowledge with you and become the best technician at your company. So check it out. Check my website out anyway, refrigerationmentor.com. We got a ton of podcasts on there, ton of my YouTube videos on there, really to share my knowledge so you get better, so you do better, so you can serve your customers, help your company, and grow. So definitely check those out. Okay, next step, get over to the website and get into that course, sign up for that course. Anyone has any questions, throw them in the chat. Let me go through, see what I missed.
Thank you very much, Trevor.
Yes,
Very
thank you very
interesting.
much for your presentation. We're going to share the links in the chat later, I think, again.
I'm going to throw it in the chat as well right now, just so it makes it easier.
Yeah.
So right there, Refrigeration Mentor/events. And you can check out the other events I have there as well. I got morning coffee with Trevor, 6:30 a.m. Eastern time each day for the next 24 days. So I got it's counting down. So you can go there and check it out.
Really great. Are we ready to start the QA session?
Yeah.
Yeah.
Let's do it.
Okay. So as I remember, we have some questions which people have asked before the webinar when they were registering to this webinar. We would like to discuss them if that's possible.
Yeah. So I got thanks for sending those to me, Vanessa. So why are we using scroll and screw compressors? Well, really, they are different design compressors. Scroll is different than screw. Screws are usually for larger industrial applications, and they do bigger capacity, bigger tonnage, bigger kilowatts. So they're moving more refrigerant, so doing more cooling. Scrolls, they are getting larger, but you'll see them in lots of different applications: air conditioning, medium temp, high temp, low temp applications. And it's just the different type of applications. Can you use a semi-hermetic? You could use maybe a semi-hermetic for that application. What type of compressors will this event cover? Semi-hermetics and scrolls. Can I replace a semi-hermetic piston for a hermetic scroll? Yes, you can. Yes, but you got to think about, you got to go and understand the differences. Scrolls and semi-hermetics run differently. They may have different components on it. You may need a check valve. You may not need a check valve. You need to make sure that it's going to be inside that operation envelope. Can it be done? Yes, I've seen it done before. Why do you want to do all that? There has to be good reasons. There has to be if you're going from a semi-hermetic to a scroll or vice versa, you have to have the reasons have to be there has to be more benefits for your customers than less. So just make sure that you understand all that. And piping is another big thing. So make sure that you look at the design of it, because you may have to put loops in for the scrolls where the semi-hermetics may not. So these are the things that you need to understand if you're going to try to do that. In low temp application, can we use inverter compressors like a mini split or VR instead of a scroll plus VFD? Can ECM technology be utilized in a compressor? Well, inverters are, I believe they're already using, I believe Daikin already has inverter compressor. And really what an inverter is, it's doing the same thing as a VFD. So inverter, variable speed drive, it's just staging, ramping that compressor up and down. So I use those terms interchangeably. So variable frequency drive, VFD, inverter. So they're doing the same thing. They're just ramping that compressor up and down and changing it. Changing the frequency. And so you're speeding it up and slowing it down. When you do that though, you need to understand what's happening inside those pipes, because when you're using a variable speed or an inverter, it's slowing that refrigerant down, mass flow slows down and increase. So you need to put special steps in to make sure that oil's traveling through, you're getting a proper heat back. So there's a whole training in itself there. Trevor, do you have any experience in mag bearing compressors? No. So I know some of them. I've done research on it. That's something I need to learn more about. I know Danfoss has the turbo core. I've learned a bunch about that, but I'm not, I haven't spent much time on them. I've been to a few sites with them, but I've never worked on them. So that's something that I'm going to learn more about this year for sure. So that's some of the questions that came in earlier. Let's see in the chat box. I've seen there's some.
Yeah, we have some new questions in the chat, I think.
Would you like to touch a bit of operation of digital scroll? Okay, well, digital scroll, that's like a whole 2-hour session I could talk about. But basically what's happening there is the scroll set is loading and unloading. So it's fully loaded and fully unloaded. So, and it's all done on pulse width modulation. It's done on time. So 10 seconds load it, 10 seconds unload it, you get 50% capacity. And it's really to match your load, match your suction load. And so you have a tight suction temperature and pressure, so you have good humidity and temperature control. What could be the reason for one head out of two of a semi-hermetic overheat? Okay, well, it could be quite a few things. It could be you took a slug and it blew out a discharge valve. It could be you're using unloaders, for an example, right? The fixed compressor is going to be the fixed side is always going to be running. So if you take a slug, for example, and it starts unloaded, well, that one there might take the brunt of the slug. Oil. So if you start to overheat, it may just overheat one side more than the other. And there's, what else could it be? Just trying to think off the top of my head, but that's a few reasons why one would overheat the other, because the other one's working all the time. And if it's unloaded and you have a high compression ratio, like we talked about, high compression ratio, more work, more heat, it's going to affect that fixed side first. Hopefully that helps and answer your question. So once again, check out my website, refrigerationmentor.com. Check out my events page for my upcoming events. And hopefully I see some of you on February 26th, because I'm going to be diving in on compressors, understanding systems. And so you are a more effective, more confident, and more efficient technician engineer out there. Thank you.
Thank you very much, Trevor, and to
Thank
everyone, participants.
Yeah,
So,
we're really grateful for all our listeners and Trevor for the great presentation. I think it was really beneficial for our listeners.
I hope to see you on our next webinars. Please follow our website and follow website Refrigeration Mentor of Trevor.
Yeah, don't forget to check out both of these sites.
Great. Thank you very much to everyone. Bye.
Yeah. Goodbye.
Goodbye, Trevor.
Bye.